Current ERPs didn't come out of the blue and were just devised from scratch. They are the natural evolution of other systems, and in the origin we can find the so-called MRP systems, which stands for Materials Requirements Planning. These systems were first used in the 70s in the area of production, and they were a way to organize the production to meet the deadlines according to the orders for the customers. And the logic is a backward planning. Let's see this very simple example we have here. Let's imagine we have a product. It could be a tricycle, for example, where we have the product A, which is the end product, the tricycle itself, which we assemble when we combine, or we assemble three elements of type C, which are the wheels, assuming they are exactly the same type of wheels we are using for all the positions the tricycle has. And we have let's say the frame, and this frame is made out of two different subframes, or different components that allow us, if we assemble them, to have a frame that we combine with the wheels, and we have the actual tricycle. So what we have here in this diagram is a representation of how I should organize the production so that I get a tricycle available by date F. So these rectangles, each of the rectangles we have here, represent the assembling or production process of each component, A, B, C, D. So we have A, and these two in between brackets is the lead time for me to assemble or to come out with an element, a component, in this case the end product A, once I have products B and C. The lead time is the time it takes for me to have a component, product, whatever it is, available from the moment I launch the assembling or production process. So if I launch an order for assembling a product A, it'll take, let's say, 2 days to get it available for me to pass it on to the next stage. The same goes for product B. These 3 stands for the lead time for products or component B. 4 days is the lead time for component C, and 5 days is the lead time for component D. In addition to that, what we have, these numbers here, is the number of components we have to come up with the product at the next level. So for assembling a product A, we need 1 B and 3 C's. And for coming up with a 1 B, we need 2 D's. So the point here is, if I want to have one product A available by date F, we need to backward plan so that we know when we need to start the production of the different subsystems or subcomponents. So if we want to get this product finished by date F or 0, okay, what we need to do is to move 2 days backwards, and at that time we need to have one product or subcomponent B and 3 components C, so that we can start assembling those items in date F-2 and get it done by date F. So we can keep moving backwards, because if we want to have 3 elements of type C by F-2, if the lead time is 4, we need to do F-2 minus 4, and we come to F-6, which is the time by which I need to start producing 3 elements of type C, because for each A I need 3 C's. Okay, and that is when I should start my production for component C. Actually, 3 elements for me to have them ready to start assembling the components by date F-2. And the same goes for component B. If we want to have B ready to be assembled at F-2, if the lead time is 3, we have to get started with B at F-2 minus 3, which is this F-5. And finally, if we want to get 1B, we need to get started with the 2Ds that allow me to get 1B 5 days before I start assembling component B. So if I move back from F minus 5 days, I will get to 5 minus 10, which is the moment where I have to get started with the 2 components of the 2 items of the component D that will allow me to start with B, and so on. So that is the way to proceed. I have a date when I want to have my final production done. I want to have this A product finished, and I move backwards, making sure that I get the right number of components in time for me to move to the next stage, according to this structure here, which, as I mentioned, is what we call the bill of materials, because it tells us where we need to get a component at different levels, so that eventually we have the end product that we can ship to our customer or to move to the next stage within the production plant. So this is something that was developed in the 70s, okay, which is the core, we have it here, of these processes we have here. So for you to understand how that was implemented, what we did first was to take into account the forecast we have and the orders we know for sure, because they are orders from our customers we need to satisfy, and given also the information we have from the current states of manufacturing and purchasing orders, when we combine that all together, what we can get is the master production scheduling, which is the MPS, and it tells us when we have to finish the production of different lots so that we can satisfy our demand. So this is the information we introduce into the module MRP, to the materials requirement planning, which performs as I described in the previous slide. But for us to come up with that, we also need to know the bill of materials, because it allows us to know how many components we have to use in each process along the production process, and we need to know how many items we have at each point in time, so that we decide whether we need to produce or not. So given the delivery dates we have according to our orders and forecasts, given the needs of materials to produce an item, and given the current amount of inventory we have of every component, we can run the MRP, and with that what we can get is the manufacturing orders and the purchasing orders, okay? And that is something we can track to make sure that we deliver on time, and that we can go back according to this loop and start all over again with the master production scheduling according to the times we are organizing our production in our company. That's, as I told you, something that was first started in the 70s. Something that was not taken into account within these systems is the fact that when we are doing this, let me go back to this slide, when we are doing this backward planning, we are not taking into account whether we have enough capacity for producing these items in the times we require them. That's why these these materials requirement planning systems evolved to what we know now as the manufacturing resource planning systems, which also are MRPs, but they were named with these two, MRP2. This was in the early 80s, so that we introduced new modules. So when we had the information of our inventory control, how many items we had, we plan to have over time, the requirements of different materials for producing an item, and the plan according to which we had to produce, we had another module which was the capacity planning that allowed us to estimate what were the actual times for us to have the different subcomponents manufactured, assembled, or purchased. Okay, and this has to do with the routing, because different components might have different routines, require different machines or resources, and different work centers. I won't get into the detail, but I just want you to know that the MRPs in the 70s didn't contain that. This was introduced so that the schedule, the manufacturing orders that came out of this system were a set of orders you could actually put into practice, because they were consistent with the capacity available within your plant. Finally, in the 19th, what happened is that there were systems like this, but in different areas of the organization. This was a very mature system, the MRPs, but we also had different systems within different areas. We have similar systems, but with the corresponding processes in human resources, finance, and so on. So what companies like SAP, which came from the finance world, started to do is to integrate these modules into a single tool with different modules, and all of them, as I said at the very beginning of this series, all of them were using the very same data for their own processes, sharing through that master database all the information they required, and that's and providing other functions with additional information they were producing. And finally, as you might imagine, ERPs that are like the main system many companies have to organize all their processes are not isolated, and it is very common to have ERPs talking to each other from different organizations. There are different protocols. This EDI, Electronic Data Interchange, is a protocol for communicating across different organizations. That this can be used for connecting to businesses or a business with a customer. But I won't get into the details, but these ERPs have interfaces that allow them to communicate. And since I will show that in a minute, there is no a single ERP that all companies use, because depending on the needs, the budgets, the existing software and so on, the culture, blah blah. So depending on many things, different companies choose different softwares available out there. So there are ways by means of which you can ensure that they can communicate and enable coordination across the supply chain, so that different elements in the organization can share information that is contained within different ERPs. And finally, I want to show you this pie chart, which I obtained from this paper, which is a very recent one, where you have a list of the major options you have for ERPs, okay? And as you can see, the main competitor is SAP, is the one you can find in most companies, but still you see that the market share is not big compared with the rest of the options, of the summation of all the other market shares. You have Oracle and many other options, okay? So this is a way that this shows that there's no single option, and that sometimes it's kind of challenging to make sure that companies communicate well, because they have to exchange communication. But this is less and less of a difficulty as IT is progressing and we have more technology available for us to ensure that that coordination occurs.